What's up, guys? In this video, I want to go over the top 5 examples that students make mistakes on when trying to identify the domain and range of a function. Okay, so the first one is going to be dealing with a quadratic. Now, for all of these examples, what I want to do is highlight where students make the mistakes, as well as what you need to know, so therefore you can get the problem correct if you end up getting something like on a test or a quiz. So for all of these, we all need to know what the parent graph is. So in this example, we have a quadratic. We need to know exactly what this graph looks like. Now, the domain, remember, is going to be the set of all x values. So that's basically going to say how far left does the graph go, how far right does the graph go, and you can see in this case it'd be all real numbers. The range is basically going to be the set of y values, which basically, on graphing, you can think about it, how low does the graph go to how high does it go? So the range in this case would be 0 to infinity. So now what we need to do is understand, well, what exactly then are the transformations doing to this problem? So we have a negative x squared, that is reflecting the graph about the x-axis, and then we have plus 4, which is shifting the graph up 4 units. So the major mistake that I see students make with this one is they apply the vertical shift first, and then they reflect it about the x-axis. So they go up 4, 1, 2, 3, 4, and say, all right, that's what that graph looks like, and then they reflect it, and the graph looks like that. Unfortunately, ladies and gentlemen, this is incorrect. You would still have your domain would still be correct because it'd still be all real numbers, but your range is not from negative infinity to negative 4. What you need to do is you need to go ahead and apply the reflection first. So what we do is we take this graph, is we're going to reflect it about the x-axis, and then we're going to shift it up 4 units, 1, 2, 3, 4. So now we can see the graph is going to look like that. Now, obviously my graph looks pretty poor, but let's go ahead and write out the domain and range so we can see. So the domain in this case is going to be from negative infinity to infinity, and the range is going to be from negative infinity to a positive 4. So again, a lot of students will do it this way, and they'll say the range is going to be from negative infinity to negative 4. That is going to not be correct. All right, the next one is going to be with a radical function. So when we're dealing with the square root function, again, we need to know what the parent graph is going to look like. So we have the parent graph, looks like this. Now the domain in this case is going to be all positive numbers from 0 to infinity. The range in this case is also going to be all positive numbers from 0 to infinity. So this area where students make mistakes in this case is they forget that they have a b in this case. So they go through the transformations, and they say, all right, yeah, I remember plus 4. That is actually going to be in the opposite direction, so that's going to be minus 4. And they go something like this. Now, unfortunately, they had the direction correct. You are moving to the left when you're adding a 4, but you're actually not going to be adding, you're actually not going 4 to the left-hand side, because this b is actually also doing a horizontal compression. And so what you need to do is you actually need to factor out that 2. When you factor out the 2, you're going to get a x plus 2. Right? So 2 represents our horizontal compression, and the plus 2 is actually going to be our transformation. So the domain is not going to be from negative 4 to infinity, right? The domain is going to be 2 units to the left. So you're only going to go 2 units to left. So that means my range is going to be from negative 2 to positive infinity. I'm sorry, not my range. My domain is going to be that. Now, one thing, and also another mistake that students will make, is sometimes they see the plus 2, and they'll shift it 2 units to the right, or shift it 4 units to the right. Don't do that. Or make sure when you're adding, that's actually going to be a shift to the left direction. Okay, now in this one we have a logarithm, and this example is actually very similar to what we just did with the radicals. For whatever reason, a lot of students, I think they just don't get as much practice with logarithms as we do with radicals and quadratics, so they forget what the parent graph is. But I think it's really important to make sure we understand it's going to have a y-intercept at 1, 0. It's going to look something like that, and there's also going to be a vertical asymptote. Okay, so the range of this graph is going to be from 0 to infinity. 0 is not included though, because there's an asymptote here. See, in this case, 2 was included. It's actually a point on the graph. That's why I used brackets, and I should have used brackets over here. Make sure I did catch that. There you go. But we're going to use parentheses because it's not included when we're dealing with infinity. That should be a bracket as well. Okay, and the range though is going to be from negative infinity to positive infinity. So again, what are the mistakes that students will make here is a lot of times they'll either like shift it 1 unit to the right or shift it 1 unit to the left. Unfortunately, ladies and gentlemen, that is not going to be the case, right? So students will go like this and they'll say, oh, it's a +1, or sometimes they'll subtract it, or maybe they might even rearrange it. So they'll say log of negative x plus 1. Now they get confused, so some students will either move it to the right 1 unit, or they'll move it to the left 1 unit. Unfortunately, both of those examples are incorrect because again, we have a b. When you have a b, that means a coefficient of your linear term inside of your function, square root or logarithm or any other function, you need to be able to factor that out. So when I factor out this negative, I'm now getting a x minus a 1. Now it's also important when you have a negative, remember ladies and gentlemen, that's a reflection about the y-axis. A negative on the outside is a reflection about the x-axis. A negative on the inside is a reflection about the y-axis. So we're going to take this graph, we are going to reflect it about the y-axis. It now looks like this. Then we have a minus 1, so that means we need to shift it 1 unit over to the right. So we're going to go over here, and now my graph looks like that. Now it's also important about this asymptote here, right? So we have the asymptote. When you reflect that graph about the y-axis, the asymptote was on the y-axis, so that doesn't change. However, when I have this minus 1, that's going to now shift my graph, or my asymptote, 1 unit to the right. So my domain in this case is going to be from negative infinity to positive 1. Again, it's not included, so I'm using my parentheses, but my range is still going to be from negative infinity to infinity. So just be careful, guys, when you have these b's. It's super important to make sure you factor them out. That's going to give you the correct transformation. And then also remember, if you have a negative, that's going to be flipping the graph across the y-axis. All right, for example number 4 and 5, I'm going to erase and redraw everything up. All right, now the next example that students will make a mistake with the domain and range is going to be with our exponential function. So again, kind of like logarithm, students just kind of forget what the parent graph looks like. This one, remember the exponential is the inverse of our logarithmic graph. So that graph is going to look like this. It's going to have a y-intercept at 0, 1. So in this case, my domain is from negative infinity to infinity. My range is going to be 0 to infinity. But again, there is a horizontal asymptote here. It's the exact flip of what we just went over with the logarithm. Now, we don't have any horizontal transformations, right? But we have some things that are going on here for sure. So a lot of times students get, there's some things that are unique about the exponential function that it doesn't happen with the same transformations of our other function. So first of all, we need to understand when we have a number 4, what that's going to do, that is actually going to change our y-intercept. That's a vertical stretch, right? So it's going to change our y-intercept to a 1, 1, 2, 3, 4. Let's move it up. But for whatever reason, a lot of times students will still like somehow have that impact the domain, right? Or like that's impacting or like shifting up or down. It doesn't really impact the domain and range. All it's doing is vertically stretching the graph. So we have that. And then here we have a base, which is a fraction. Now remember, there's a couple different ways we can look at this. I can rewrite a 1/2. A 1/2 is the same thing as 2 to the negative first power. So technically, if I have a 1/2 x, right, I can rewrite that as a 2 to the negative x, which is the same thing as a 2 to the negative x. Now students will be like, aha, I got it. I got a transformation. But here's the cool thing, guys. If I take this graph, right, and you reflect it about the y-axis, right? So now it goes up to 4, but now you reflect it about the y-axis. Ladies and gentlemen, the domain and range have been unchanged, right? There's nothing that's mattering. So whatever I do horizontally, since the domain is from negative infinity to positive infinity, anything horizontally is not going to change. So this negative does not impact it. The logarithm was different because the logarithm had a restricted domain of 0 to infinity. So if I reflected that about the y-axis, it was now from negative infinity to 0. Here, since my domain is all real numbers, it doesn't matter if I reflected about the y-axis at all, right? And again, vertical stretch or compression is not going to impact. Multiplying by a positive number is not going to impact my range. That's just stretching or compressing the graph. The only thing that is happening to this graph would be shifting it down 1 unit. Because remember, there's a horizontal asymptote here. So if I originally had a y-intercept at 4, if I shift it down 1, it's going to be at 3. And then that horizontal asymptote was at 0. That's now going to be at a -1. So the graph would look like this. There's no one individual mistake that I see students make on this one. I feel like they mess with the domain when nothing's happening to it. And a lot of times they'll get all the transformations wrong with that 4 and the 1/2. But in reality, those aren't impacting. The only thing that's impacting my domain or my range here is the -1. So my domain in this case is going to be all real numbers. And my range is going to be from -1 to infinity. All right, now let's get into the last one, which is kind of a hidden one on transformations. All right, right, so now what we have is what we call a rational function. Now, when we are simplifying a rational function or trying to identify the domain and the range, there's a couple things we need to understand. When you're dealing with like a logarithm, you can't take the logarithm of a negative argument. Same thing with a radical. When you're looking at a rational function, you can't divide by 0. So it's very important for us to identify the values that are not going to be included in our domain. So the first thing I'm going to do is I'm going to factor everything out. So I get an x plus 1. Let's see, what two numbers multiply give me -2, add to give me -1. That'd be a x minus 2 times a x plus 1. This is important because now you can see this factored form, right? X plus 1 is the same in the numerator and the denominator. Since these are separated by multiplication, I can divide these expressions out. Therefore, that's going to leave me with a simplified version of 1 over a x minus 2. Now, this got divided out. This is what we call a removable discontinuity. That is going to show up as a whole. So it's still a value that is not a part of the domain. So x, we know, cannot equal -1. And we know if I put 2 in the denominator, 2 minus 2 would be 0. You can't divide by 0. So we also know x cannot equal a 2. Now, furthermore, that's enough to go off of the domain, right? But to understand the range, I don't want to really find the inverse and go through all that. I just want to look at this, what this would be graphically. So if we have a hole, and we have an asymptote, and we have a reciprocal function. Let's go ahead and graph this because you should know what the reciprocal function looks like. It's going to be this little graph right here, and it's going to have a vertical asymptote and a horizontal asymptote. So the graph looks like this. The domain is basically from -infinity to 0, 0 to infinity, and then the range is going to be -infinity to 0, and then 0 to infinity. So if I take this graph and I'm shifting it over 2 units, well then now the graph is going to look something like this. My horizontal asymptote didn't change, but my vertical asymptote has now changed, right? So now the graph looks something like this. Again, it's always approaching these asymptotes. Okay, so we can go ahead and write the domain. The domain is going to be from -infinity, right? So all the way over to infinity, and then it's approaching this asymptote, but it's never going to hit it. So that's from 2, union 2 to infinity. But what about the range? And what does this hole do? What happened to this hole? At -1, there's a hole in the graph. And actually, I forgot, oh, I didn't even include that. Dang it, I made a mistake. It's very important to graph the hole because, ladies and gentlemen, that's a discontinuity, right? So my domain was actually all wrong. My domain is -infinity to where this hole occurs, which is at -1. And then we have from -1 to +2, and then from 2 to infinity. All right, but what about the y values? We know the horizontal asymptote is not included in the domain, but now we need to figure out, well, what about the y value here where this hole is? So all you need to simply do is plug in the value of your hole into your simplified equation. So if I take a y of -1 and I plug it in of -1 minus 2, -1 minus 2 is a -3. So y of -1 is equal to a 1/3. So what that means is this coordinate, this is the coordinate point, this is my hole, -1, -1/3. That is going to be my hole. So we know -1 was not included in the domain. That's why I use the parentheses. But also, -1/3 is not going to be included in the range. So if we're going from down to up, -infinity is going to go to -1/3. So my range is going to be from -infinity to a -1/3, union -1/3 to 0, and then connect that with 0 to infinity. And there's really no common mistakes I'd see that students would make of theirs. It would really just be, I'll tell you, the common mistake that students will do is they'll forget what the hole is. They'll just go off of the asymptotes and they'll forget that either this hole, they might do the domain correctly, but they'll forget that there's a hole and there's no y value. So there you go, ladies and gentlemen. These are the top 5 domain and range problems I see students make. I hope you are not one of them.